In the previous videos, we have seen how to write some Python code. Now we will take a step back and look at how to set up your programming environment for working with Python. In order to develop Python programs, you need at least three things: an operating system, a text editor, and a Python interpreter. I recommend that you use one of the desktop operating systems such as Windows, Mac OS, or a Linux. Although theoretically you can use a mobile operating system to develop Python applications, your productivity will not be as good as when using a desktop operating system. You will also need a text editor to create Python files or scripts. I recommend that you use something that provides syntax highlighting features and auto indentation. Last, you need a Python interpreter for executing Python code. Because Python is an open source programming language, you can find different implementations of the interpreter, but using the standard implementation will be sufficient for this course. To become a programmer, you need to be comfortable with using a desktop operating system. In particular, you should be familiar with creating, copying, deleting, moving, and viewing files and folders. Learning these is outside the scope of this course. However, there are many online tutorials that will help you gain confidence with using an operating system. Also, I strongly recommend that you learn how to use your own operating system terminal or command line. This is important because all the programs that we'll be writing in this course will run on the terminal, and testing these applications and these programs will be much easier if you are familiar with using the command line or the terminal. To run Python programs, you need to install an interpreter. You can download the interpreter or the standard interpreter from this website, python.org. The latest version of Python is Python 3.8. The one that we'll be using in this course is 3.7, and the one that we'll be using ships with Anaconda, and we'll talk about Anaconda shortly. Keep in mind that there are two flavors of Python. There is Python 2 and Python 3. Python 3 itself was released sometime around 2008, and it was not meant to be it's not meant to be backward compatible with Python 2. So if you develop something using Python 2, it will not run in a Python 3 interpreter. Also, if you develop something using Python 3, it will not be backward compatible with Python 2. And you can find some differences between Python 2 and Python 3. One simple difference is the print function. In Python 2, the print used to be a statement. So if you wanted to print something or display something to the screen, you'd have used print and then double quotation and whatever the string that you have printed. This was in Python 2. This doesn't work in Python 3. In Python 3, you need to use the print function, and the way to do it in Python 3 is to use print, and then you open parentheses, and then you type the string, and then close parentheses. So you need these parentheses in Python 3. It doesn't work without these. But in Python 2, you could have done it without the parentheses. So this was used to be called the print statement, and this is called the print function and not the print statement. So this is just one difference between Python 2 and Python 3, and we will see more differences between Python 2 and Python 3 throughout this course. But the one that will be focusing more in more details, or the one that we'll be studying in this course, is going to be Python 3. So we're not going to be focusing on learning Python 2 features. In this course, we will use the Python interpreter that comes with Anaconda, and Anaconda is a free open source distribution of Python. Anaconda comes with a number of tools that simplify the process of building scientific computing applications. So these kind of applications include, for example, the applications that are used in data science, for example, and machine learning. Now, you don't need to be familiar with these terms. You're going to come across these terms once you reach your BTech program. So you're going to be I'm pretty sure somewhere in your studies you will see the term data science and machine learning. But Anaconda is used heavily, or quite heavily, with developing scientific computing applications such as data science and machine learning. That's because it comes with a number of tools that enable you, or it makes the whole process quite easy. So for example, it comes with package management tools if you want to install third-party package management tools, and it also comes with a number of integrated development environments. So it comes with a number of integrated development environments, which we call for short IDEs. We'll talk about IDEs in more details we'll talk shortly about IDEs in the upcoming slides. If you want to run Python, there are two general ways to run a Python program. The first one is to run the Python interpreter as an interactive shell. And to do so, what you have to do is you need to type the Python command in the terminal, and this will open the interpreter as some kind of an interactive shell. What you can do here, you can type the Python statements one at a time. So this is a Python statement. So this is a print. This is our Python statement, which is calling the print function, and we have seen this in the previous videos. Now, as soon as you type the statement and hit enter, you immediately see the result of the statement that you have written in the top. Here we are writing again another statement, and the result of that statement is showing here. We are assigning two variables here, x equal 1, y equal 13, and then we are printing x plus y. 1 plus 13 gives us the result 14. So as soon as we type a statement, we get the result immediately. This is called a REPL shell, or a read, evaluate, print loop, or an interactive shell. So this is one way to run Python code. The other way to run Python code is to put all your code in one file. For example, hello.py. Okay, and you need to note the extension. You need to make sure that the extension is .py, especially if you're working with Windows. Although this is not necessarily a strict requirement, but we prefer that if you keep all your Python code in a file with the extension .py. Now this is a text file, and we'll talk about text files in the next slide. But what you do, you use a text editor and you write some code, and for example, you save all of this as hello.py, and then you invoke the Python interpreter. The way to do that is to use the Python command. Use the Python command, but this time you supply your text file name. And what will this do? It will invoke two things. It will invoke the compiler and the interpreter. Now, the compiler will first translate your code into some kind of a primitive language, something that is easy for the computer to execute. And then the interpreter will take these instructions and will execute them one at a time. And for each instruction that you have written in the program, you will get the output for those instructions. A Python program is usually written in a text file that is saved as a .py file. A text file is a file that has some readable content if it is opened with a text editor. Now here is a file that you see in the right hand side, which is a text file, and this is actually a Python file, and we're opening this using a text editor, a plain text editor, and you can clearly, you know, recognize all the letters and the words in this file because this is a text file. The opposite of a text file is what we call a binary file. Binary file. Now, one example of binary files are images. So if you take any of the images that has the extension PNG or GIF or JPEG, all of these are binary files. And in the left hand side here, this is a PNG file that we have opened using a text editor. As you can clearly see, the content of this file is not readable because we have opened it using a text editor. So this is the difference between a text file and a non-text file. So Python is a text file, or Python programs usually written as text files, which you can open using any text editor available to you. To work with Python, I recommend that you use a text editor that has features such as syntax highlighting, auto indentation, code block selection, auto completion, and advanced search and replace. The two ones that I strongly recommend is Sublime Text or Visual Studio Code. Any one of these is going to be good or sufficient for you in this course if you plan to go down the route of using a text editor, and they are available under different operating systems. So you have they come you can install them in a Windows, a Mac OS, or even a Linux. What we will do in this course, instead of installing the individual tools when setting up the programming environment, we will use an integrated development environment. An integrated development environment is a collection of tools that allows you to edit, run, and debug Python programs. There are many IDEs to work with for Python. So for example, you have PyCharm, and this is a really good IDE if you want to do serious Python programming and Python development. However, it has some license cost if you're using the professional edition. It is available for free for students, so you get a free license for 1 year if you are a student to use the full professional edition. The one we will use in this course is the Spyder integrated development environment because it ships along, or it comes along with Anaconda. And this is the one that we'll be using for our course.